Hey YouTube, it's Booth Dog here. It's Monday, and I thought I'd go through a shopping haul I'm very excited about. So I recently purchased a new instrument for use with my taiko, the Japanese drum, and I thought, why not go through all of my, instruments for the taiko, my drumsticks, my bachi. So let's get started. First, here's what I purchased. It comes in this very nice case, I must say. And it's not quite plastic, but it's also not bamboo. It's like a fiberglass kind of thing. And it's this delightful Japanese flute. And as you can see at the end inscribed is the Japanese kanji for 8. That has to do with the tuning of the instrument. I'm very excited to jump into this and learn how to play this well. We'll see how long that takes. I think it's going to be a few years. All right. Otherwise, we have my standard Chu Daiko Bachi. So that's playing the large drum, but it's on the ground. It's not quite as large as we have. I've had these for, I'd say maybe 10 years or so. They're a little beat up at the end, but great size. We have my Silk Daiko Bachi. So this is for use playing certain songs. They're a little longer, so when we do twirls with them, they're much more impressive. In addition, I have my O Daiko Bachi. So those are the huge drums on the stands that you play like this up here. So they're much larger, as you can see. Get a bigger sound. We have my Nicho Daiko Bachi. Nicho, that's one of the songs played in Hiroshima. Of course, we all know Hiroshima. And this is one of the songs that's been preserved there for many, many, many years. And these bachi, they're large, but you can see they're quite light. So it's useful when playing this particular style of song. We have my Inori Bachi. So Inori, that is a particular song that we play. And you can see they're quite large and they're very dense. So you get a different sound using them. Very different. We usually play those up as well. And we're getting to some of my favorites. We have my Shime Daiko Bachi. You can see these are much thinner and lighter. They're for use when playing the smaller rope or bolt-tied drums, and they're thinner and lighter so you can play much faster with them, get much more precision from them. My favorite instrument. And finally, I have another pair of Shime Daiko Bachi. They're a little larger, but they're lighter, so they have a really nice snap to it when playing. Well, those are my bachi. That was my shopping haul for today. Let me know what you guys think about any of this, and we'll turn it over to Mr. Boothman for today's lesson. Good morning, happy Monday. As I'm sure you've no doubt heard, starting this week we will have a bit of a different schedule for the rest of the year. So Monday, Tuesday, Thursday, Friday is going to continue just like it's been. Wednesdays, however, each week will be work days for you. Okay, so Wednesdays, there will be no new assignments or exit tickets or lessons on Wednesdays for any class. Okay, instead it will serve as like a catch-up day, a work day for each of you. Each subject is going to have specific office hours that day. And in answer to so many of your questions, okay, let's talk about retakes and how those are going to work for the rest of the year. So I'm going to take advantage of these Wednesdays and use them as retake days for pre-calc specifically. The official math office hours on Wednesday are going to be 10 to 10:30, but I will make myself available for most of the day. Okay. Retakes will be held one-on-one through a Google Meet session with me. So I'm going to share a link on Google Classroom. It should have been posted with this video. You can click the link and then sign in through your AguaFria email address, and you should see appointment slots each Wednesday from now until the end of the year. Whenever you'd like, go ahead and click on the appointment time you would like. They're 20-minute slots. And let me know when you're choosing that appointment time. There's a place to add a description. In that description, let me know which learning targets you're thinking about retaking, or what maybe you're just trying to meet with me for some one-on-one tutoring. That's fine as well. Just let me know. And then each Wednesday, I'm just going to follow our appointment time. I'll invite you to Google Meet. And then one-on-one, we'll practice, we'll answer your questions, and I'll give you a retake then and there. Okay, so that's how we're going to handle retakes for the rest of the year. This Wednesday, it's a great opportunity for this. So let me know if you have any questions. Additionally, the EOCA this year. Okay, the format this year is going to be a little different. I'm working on finalizing what this will look like for you with some other teachers. It will either take the form of a sort of project, or it will be a more traditional multiple choice free response exam. Okay, we're still deciding, so more details coming soon. Either way, it will not be worth 20% of your final grade. The number I think I'm aiming for is about 10% of your final grade. Okay, so not quite as high stakes as usual, but still a pretty decent amount. Again, more information coming later. Lastly, your exit tickets this week will be just like your exit tickets from last week, where you'll answer some basic questions from the day's lesson. So make sure you get that done by midnight each day. Otherwise, let's jump into section 8.2. All right, so 8.1 was all about what a sequence is, how we define sequences, and the two main types of sequences that we study. That was 8.1. 8.2 is all about what we call a partial sum. So suppose we have a sequence of numbers, a 1, 2, 3, 4, and so on. Then we define the partial sums of this sequence, use S for sum, as, well, the first partial sum is the first term. The second partial sum is the first term plus the second term. The third partial sum is the first term plus the second term plus the third term. The nth partial sum is the first plus the second plus the third, all the way to the nth term. Okay, so first partial sum, second, third, and then all the way to the nth partial sum. So pretty straightforward concept. We're just adding a certain number of terms from our sequence. So we can answer questions like, let's look at example 1 here, part A. They're telling us that the nth term of this sequence is 1 over 2 to the nth power. Find the first 3 partial sums and the nth partial sum of the sequence given by this definition. Well, the first partial sum is just the first term. What is the first term? Well, a1 is going to be 1 over 2 to the first power, which is 1/2. The second partial sum is going to be a1 plus a2. Well, we have a1. We need to know a2. So a2 is 1 over 2 squared, which is 1 over 4. So the second partial sum is 1/2 plus 1/4. We need a common denominator. Once we get a common denominator, add these together, 3 over 4. The third partial sum, a1 plus a2 plus a3. So that's 1/2 plus 1/4 plus we need a3, which is 1 over 2 cubed, or 1 over 8. All right, we need a common denominator for all 3 here. We get that, we add these together for a total of 7/8. And finally, the nth partial sum. Okay, it's just going to be 1/2 plus 1/4 plus 1/8 all the way to, what's the nth term? 1 over 2 to the nth power. And that's it. I would like you to try B yourself. So same idea, okay? Just when you're finding each of these terms, you're using 1 over n minus 1 over n plus 1. And then go ahead and check your work with the guided notes answer key that I've posted. All right. Let's talk about something a little different. Now, I don't know about you, but having to write out, even just the 4th partial sum here, but what if I go all the way to the 10th partial sum or the 20th partial sum? This is a lot of numbers to have to write out separately, individually. It takes up a lot of space. Okay, mathematicians, I've said before, we like our shortcuts. We like notation that's very succinct and precise. So we have invented a special notation for this. It is known as summation notation, or more commonly, sigma notation. So here is the Greek letter sigma, and in math, this letter stands for a sum. Okay. Now, suppose, let's just take that last example. We know the nth term is 1 over 2 to the nth, or 2 to the nth power. Okay. How would we write that instead of writing out all of these terms here? How could we use this notation to simplify? Well, instead of n, okay, I'm going to use the variable k. Why do we use k? It's just convention, okay? Which means instead of the nth term here, an, we have ak. And suppose I'm adding all the terms up to this nth term. So the way we write this sigma notation, okay, we have the variable k here. That's just, again, the subscript. It's the number of our term. And on the bottom of our sigma, we write where k is starting. Okay, so for this example, let's just say we're starting at k equals 1. So that means we're starting at the first term, a1. And I'm going to stop at the nth term. I want the nth partial sum. So I'm going from k equals 1 all the way to k equals n. So the sigma tells us that we're adding. This is the term, each different term. Okay. The number we write below sigma is where we're starting, which term we're starting at and the number above sigma tells us what term we're ending with. Let's look at some examples, because this notation is very strange if you've never seen it before. Okay. Those of you going on to AP Calculus, BC particularly, you'll be very familiar with this notation. Okay. And even AB, actually, you'll see this notation from time to time. Let's look at part A from example 2. All right, so the sigma notation is telling us that we're adding. We're starting at k equals 1, and we're adding every term from k equals 1 all the way to k equals 5. And what does each term look like? K squared. So what does this equal? Well, we're starting at k equals 1, so that's 1 squared. And we're adding every term from k equals 1, 2, 3, 4, all the way to 5. And we're stopping at 5. We're stopping at this 5th partial sum. And then we just simplify this. So we have 1 plus 4 plus 9 plus 16 plus 25. So what does this add to? 10, 20, 55. And that's it. That's all there is to this. So our notation is very strange, but it allows us to write this pretty long sum in a much shorter way. Let's do part B, and then I'll ask you to do part C yourself. And again, check your answer with the answer key that's posted. Okay, so instead of k here, we're using j. J equals 3 to j equals 5 of 1 over j. So each term looks like 1 over j. And again, we're taking every value for j from 3 to 5, and we're adding all of those together. So we have 1 over 3 plus 1 over 4 plus 1 over 5. We get a common denominator, we add these together, and we get 47 over 60. All right, please try part C yourself. You should get an answer of 45. Okay, so it's just following the same idea. Last thing I'd like to do today. Can we take this long sum, starting with that, can we go backwards and write it in sigma notation? So I'm going to do A together, and then I'll ask you to try B. All right, so let's first identify that we're adding. It is a sum, so we have our sigma. And what does each term look like? Okay. Each term is some number cubed. And here's the key question we need to ask ourselves when we're using sigma notation, when we're converting to sigma notation. How does the term number relate to the term value? So for the first term, we have 1 cubed. For the second term, we have 2 cubed, and so on. So it looks like our term number is being cubed to give us the term value. So term number, that's k, so we have our term number being cubed, and we're starting with the first term, and we're going to the 7th term. And that's it. That's all we need to do. I'll go ahead and do part B with you as well, just because there's a little difference here. How does the term number give us the term value? Well, it looks like we're just taking the square root of a number. So the square root of k. Now, if k is our term number, what are we starting at here? Are we starting at k equals 1? Is the first term here the square root of 1? No, it's the square root of 3. So we're starting with k equals 3. In some sense, we're starting at the 3rd term in this sequence, and we're adding every term up until the 77th term. So we can start and stop wherever we'd like. Okay. Totally depends on our sequence, our sum. And that's as far as I want to go for today. Okay. We'll look at partial sums of arithmetic and geometric sequences tomorrow, so we'll relate this back to the types of sequences we've studied. I get that sigma notation is really weird to start, but I promise the more you see it, the more you practice with it, the more comfortable you'll get with it. So tonight, please make sure you do that exit ticket by midnight, and I encourage you to get started on the 8.2 independent practice, anything that has to do with sigma notation and partial sums, and we'll look at some more examples tomorrow. All right, have a good one. All right, thanks, Mr. Boothman. Thanks, all of you, and I'll see you guys tomorrow.